Okay, so we're going to finish this information. We've already talked about how to graph a polynomial equation. So we did that last class period where we graphed this equation here. It was in standard form and in factored form. So we already talked about all of that. These steps that we have here, I'm actually going to use a lot today, so keep these in the back of your mind because we are going to be using these quite frequently for the remainder of this page. So we already talked about this portion, so let's look at the bottom two. I'm going to do this question with you. You're going to do this question on your own. And in this question, it says that you need to identify whether the graph is even or odd, and if the leading coefficient is positive or negative. And it should say in there that you're also trying to find the equation for that function. So for this question, I'm going to start off with putting my arrows at the end first, because these should be arrows. And I'm going to use the steps that are at the very top of the page. Okay, so these steps are usually to graph it. So somebody followed these steps in order to graph that function. So I need to find, I can't factor anything, so that's the goal of this. I need to find the zeros in multiplicity, I need to find the end behavior, and I need to identify the y-intercept. So on this portion down here, first thing I'm going to do is identify these x-intercepts. These are my zeros. So I have, looks like, 3 x-intercepts. So underneath it at the bottom, I'm going to put my x-intercept. So this is x equals -3. I have x equals -2. And I have x equals 1. Those are the x-intercepts that I have. A little bit below that, there's methods to my madness. I'm going to put the multiplicity. For the multiplicity, I'm just going to label m as the multiplicity. If I was to look at this point here, Euridia, what's the multiplicity for this? Is it 1, 2, or 3? 1, because if you draw a line through it, it's literally like a linear function's been graphed through that. What about for the next two? Are these also multiplicities of 1, or is it going to be different? Well, if it was 2, remember if you look up at the top of the page over here, multiplicities of 2, it's going to bounce off of the x-axis. Does that bounce off of the x-axis here? No, it literally crosses through. So this is going to be multiplicity of 1. And what do you think x equals -2 is going to be? 1 again. And what about x equals 1? That's it. All of those are a multiplicity of 1. If it's going to bounce off of the x-axis, guys, you're going to be able to tell. In that space in the middle, I know I need to write this equation in a minute in factored form. How do I get this to be in its factored form? Think about it first. If you're having to factor something, you're having to set it equal to 0. What do you think this would look like if I was going to write it in its factored form? Hussein? X plus 3. All you're doing, guys, is you're just adding 3 to each side. If you add 3 to each side, it's going to give you x plus 3, which will equal 0. So we're going to put x plus 3 here. What about for the next one? X plus 2. And then the last one? You can actually do the work for this, or you can just rewrite it. It doesn't matter. So those are my factors. Before I write my factored form, I need to also identify from the top of the page the end behavior and the y-intercept. So for my end behavior, if I look at the graph, it's a down-up graph. So this is down and up. If you look back at the first page, if you still need it, Valerie S., what's the end behavior mean? What's the leading coefficient going to be, and what's the degree going to be? So Valerie S., what's the degree and what's the leading coefficient? Say it again. Odd for the degree, okay. And what about the leading coefficient? Is it going to be positive or negative? No, try it again. Remember, this one's going down, then up. Positive, there you go. Leading coefficient should be positive. And again, the end behavior is down first, if I could correctly write down, and up.
The leading coefficient, when you have an equation, how do you know it's negative?
So if you look at the chart that was on the front page of this packet, this is where Valeria was getting it, or Valerie was getting it. It literally says here, when you have a down-up situation, you have an odd degree and a positive leading coefficient. So that's all she was looking at. Okay. So we've identified the degree, the leading coefficient, and we actually have the factors. So down here in its factored form, I'm going to kind of put like the skeleton for what it's going to be, and we might not be 100% done with this. It says f of x equals, so you can either put f of x or y. I have 3 x-intercepts, and that's going to be at x plus 3. I left a space at the front for a reason. X plus 2. And x, I think that was minus 1. Yeah, minus 1. Why do you think I left a space in the front? I need a leading coefficient. I know the leading coefficient is going to be positive. That's what Valerie told me, but I need to know what the exact number is going to be. In Algebra 2, you usually put an a there, or some variable to represent some number. Now I need to figure out how I'm going to find it. What was the fourth step at the top of the page that we didn't use yet? The y-intercept. Okay, so we already know the y-intercept. It's this point right here, which is 0, negative 6. If you think back to Algebra 2, when you're trying to find a missing point on your graph, or an equation for your graph, take any point that is on your curve, so any point at all that's on this blue curve, and you can plug it in. The only thing you cannot use, so pay attention because I know somebody's not, you cannot use the x-intercepts in order to find your a value. You cannot use the x-intercepts. Why, you ask? Because you're literally using the x-intercepts to write your equation. Do not use the x-intercepts because it's going to give you a false a value. You can pick any other value that's on this curve, just not the x-intercepts. So I'm going to take 0, negative 6, and we're going to plug it in for the x and the y. Remember, y is f of x. It's the same thing. So for 0, negative 6, I'm going to substitute in negative 6 equals a, 0 plus 3, all the way to 0 minus 1. Don't say, oh, everything cancels at 0. No, guys, you're adding. So we're going to have a, 0 plus 3 is 3, 0 plus 2 is 2, 0 minus 1 is negative 1. These 3 numbers you have to multiply. What's 3 times 2 times negative 1? Is that my a value? What do I still have to do? Valerie told us a while ago, she said your a value, your leading coefficient, should be positive. If you simplify this and you don't get a positive answer, you're in trouble. Your a value for this should be a positive 1. So in that space for my answer, I'm going to rewrite f of x, or you can put y. You don't need to put a 1. I'm just going to write it here for temporarily, and then put x plus 3, x plus 2, and x minus 1. Remember, each of those multiplicities for these binomials, for the x-intercepts, each of the multiplicities are 1. If you want to put a 1 on here, you can for each of those parentheses, but it's not going to change your answer. On tests and quizzes, this 1 will not be there. So please don't look at me crazy and say, Ms. Tapia, the answer's not there. No, it is. I'm just putting that 1 there to remind you that there should be a leading coefficient of positive 1. That's your answer. So for the question at the end of this page, same row, all the way at the end, I want you guys to do it. Before you do it, though, follow the steps that are at the top of the page and look at the graph. Is there a nice, pretty y-intercept? No, that's definitely at some kind of decimal. So the only other point that you can use, or that I would suggest using, is this point right here, which is 2, 5. So on your graph, make sure you bubble 2, 5 so you actually see that as a coordinate in case you can't, and go ahead and solve. I'm going to give you guys 3 minutes, because on your test and quizzes, I always plan these for 3 minutes. Go. For the degree, for this guy. Odd. And what's your leading coefficient? Negative. Thank you. The reason why is because the end behavior goes up to the left and down to the right. You always read it from left to right. So as we said earlier, there are 5 x-intercepts that I'm bubbling in red. So you should have written binomials for each of those. So down here at the bottom, I'm going to put f of x equals a, because I know I'm going to have to find out what that leading coefficient is. You should have had x plus 3, x plus 2, x plus 1, x minus 1, and x minus 3. Those are your factors. What's the multiplicity on each of those? They're all 1, every single one. None of them are bouncing. None of them have a line kind of wiggling through it. We definitely said that we need to use the point 2, 5, because if you're solving it, you need to figure out what the point is, some point on your graph, and we couldn't use the y-intercept. So 5 is going to equal a times 2 plus 3, 2 plus 2, all the way down to 2 minus 3. So 5 will equal, we're going to have a is 5, 4, 3, 1. Please don't put 2 because you're used to counting down. And negative 1. Have I missed anything? 1, 2, 3, 4, 5? Should be all of them. 5 times 4 is 20. What's 20 times 3? 60 times 1 is 60, and 60 times negative 1 is negative 60. So 5a will equal negative 60a. When you divide both sides by negative 60, 5 over 60, I can reduce that. It'll give me negative 1 over what? My question to you guys, is that negative like it's supposed to be? Yeah, the problem at the top, thanks to Itzel, said that it's supposed to be negative, so I need to make sure that 1 over 12 is negative. It is okay to have a fraction. You didn't do anything wrong. So for my answer at the top of the page, I'm going to rewrite this as f of x equals negative 1 over 12, and then rewrite all of your binomials. Ran out of space, but all of this is your answer. I want to mention one thing before we flip the page. Remember how we said we had 5 answers, 5 x-intercepts? What's the degree for this? 5. There is 1, 2, 3, 4, 5. All of these are being multiplied, right? X plus 3 times x plus 2 all the way down to x minus 3. You're multiplying all of those. When that happens, to find your degree, you're just going to add all of these numbers. So for the 5 degree, we're going to have 5 x-intercepts. Same thing over here. So for the last question we just did, there were 1, 2, 3 for your binomials. There was 3 of them. They each have a degree, or each have a degree of 1 or multiplicity of 1. To find that degree, we're just going to add 1 plus 1 plus 1, which is 3. That is why we had 3 x-intercepts. So all of the things that I gave you guys at the beginning of this kind of packet was to make sure you guys remember it later on. And we even wrote this at the top of the page. Even degree has an even number of zeros, and further over, we said if we have an odd degree, you have an odd number of zeros. So all of that stuff is coming back. All right, before we move on, questions or concerns about this last question here? All right, let's look at the next page. Even though we've already graphed these, I'm going to graph numbers 5 and 6. I'm graphing 5. You guys are graphing 6. And as you notice for number 5, it has a 2 binomials, and it has an exponent on one, which is fine. Whenever you're graphing, I'm literally going to use the steps that were on the last page that we were just on. So factor, which is already done for us. We're going to find the zeros in multiplicity, the end behavior, and the y-intercept. So we're following the same steps that we just saw. So for question number 5, the first step that I said was to find the x-intercepts or zeros in the multiplicity. So we're going to set p of x equal to 0, and then x minus 1 squared, x minus 3. Remember, when you're finding your x-intercept, you're really just taking that polynomial and setting it equal to 0. I'm just going to take x minus 1, set that equal to 0, and x minus 3, set that equal to 0. So far, it looks like we're just going to have 2 x-intercepts. We'll talk about the degree in a second. On x minus 1, what's the degree for that, or the multiplicity? Multiplicity for this is 2. What about the multiplicity for x minus 3? So I have the multiplicities for each of these. That multiplicity is also going to help us with finding what the degree is for the entire polynomial. So we did step 2, which is finding the x-intercepts or zeros and the multiplicity. At the top of the page, because I really don't have too much space, I'm going to label the end behavior, which is looking at your leading coefficient and looking at your degree. So Valeria, what's the leading coefficient? Just kidding. Edgar, what's the leading coefficient for this? You're looking at the front of this equation, 1. If you don't see a number, put a 1. So your leading coefficient is a positive 1, and the degree. So just like how we did on the last page, we're going to take 2, and we're going to add it to 1. What's 2 plus 1? Look back on the other page, Edgar, and tell me what's the end behavior going to look like. Is it up, up, down, up? How's it going to look? I'll wait for you. You have a positive leading coefficient and an odd degree. Down, up. So I'm going to highlight that, down, up. The last step is to find your y-intercept. I'm literally going through the same steps that we did last class period. So for the y-intercept, I'm going to take y equals, wait, I don't have a graph this time. How do I find the y-intercept for this? When x is 0. So we're going to plug in 0 for x. So 0 minus 1 squared, 0 minus 3. Y'all know how to do this. We're going to make this negative 1 squared, negative 3. Negative 1 squared is just 1, times negative 3 is just negative 3. That's my y-intercept. I have everything I need. Remember, when you have an odd degree, you should have an odd number of roots or x-intercepts. Even though there's just 2, x equals 1 is counting twice because it's going to bounce off. So let me graph this over. We're going to start with my x-intercepts, which are 1 and 3. And we have a y-intercept at negative 3. Remember, this graph is starting down and then going up. So it's going to start from a downward direction from the far left. It's going to go up through the y-intercept. At 1, it's going to have a multiplicity of 2. Multiplicities of 2 bounce off of the x-axis. So let me graph this up. It's going to bounce off of the x-axis. And then at 3, it's going to cross through it like a linear function. This is going to be your graph. Something similar. So something similar to this will be your graph. So right now, you guys do the same thing, but for number 6. Don't let that fraction for your leading coefficient mess you up. You're literally doing the exact same thing. Question, Joseph?
Yeah.
What's up?
Is there a way to figure out how high the bump is between 1 and 3 goes?
How high what?
Like you know how it bounces off the back?
Oh, so like this length?
Yeah.
Not really. You could actually do like literally plugging in like the x values in this equation for like 1.5 and 1.3. But I'm not having you do that. On tests and quizzes, this is what I want to see. Yeah, if your graph like yours on your paper is like down here, I'm okay with it. As long as it hits those points and ends in the correct directions, I'm fine. All right, so I'm going to give you guys the same 3 minutes. Please look up to see what question 6 is so you don't mess that up. I'm asking you to do the question 6 right next to it. If you finish with question 6, try number 7. After the timer goes off, I'm just letting you grasp the function. I'm not letting it work out anything. All right, so for question number 6, all I'm doing is graphing it out. So for this one, you should have had 2 x-intercepts at x equals -2 and +3. It should have had a y-intercept at what? +3, and what's the end behavior? Up in both directions. This should have just been a w. So something like this. It's going to bounce off of the x-axis for both. So I do want to mention for question 7, even though I'm not doing it, I at least want to mention what you should think about when you're solving it. Is there any questions from 6? For question 7, what's the leading coefficient here? Nope. 1. X is not a number, guys. A coefficient is just a number. If you need to write out that your leading coefficient is 1, do that. What's the degree for this one? 3. That is right. And what does this x mean? What's the whole point of it being there? It's also an x-intercept, and that x-intercept is at 0. So if you need to write that out, write it out. I'm not going to do question 7 with you, but we are going to do question number 10. So question number 10 is what we're going to do next. Okay, for question number 10, this one says, using synthetic division provided, write the original polynomial in both standard and factored form and then sketch the graph. Question number 10 has a little bit of a typo. Instead of it being positive 120, it should be positive 128 and negative 128. So make that into an 8 at the very end. So check your paper. It should be positive 128 and negative 128. Okay, so first things first. We did synthetic division a couple classes ago. I can write standard form just by seeing this top row. What's the highest exponent for this? X to the 5th? No. Are you just guessing? Start from the right-hand side. So start from this 128. What is this number? It's your constant. So we're going to put C on top of that, which means the next one's going to be x to the 1st and then x squared. The highest exponent here is x to the 4th power. So take right now those coefficients and that information and write it out in standard form. So we can write this as f of x equals, your a value is negative 1 because it's your leading coefficient. That's the number. So negative 1 x to the 4th power plus 10x cubed minus 24x squared all the way down to 128. So get that done right now. That's easy. No, so don't worry about the rest of it. We're just looking at the very top row. If you think back to what we did for long and synthetic division, which is here. For long and synthetic division, we just took the leading coefficients here and we wrote them in the first row. That's all I'm showing you. All right, for the next part, now I need to interpret what that leading coefficient, or not leading coefficient, that synthetic division is. So all of this synthetic division, it means something. It looks like they were a little incomplete with this, so I want you to actually subtract. 128 minus 128 is what? 0. So, okay, there's no remainder here. There's no remainder here. And there's no remainder on the last one either. So those orange little boxes are helping you with the remainder. The factor and remainder theorem, we've already talked about it in Algebra 2. But by the factor and remainder theorem, it says that in order for something to be a factor, it must be using synthetic division and have no remainder, or even long division. It should not have a remainder. So by having 0 here for your remainder, that means that x equals 4 is going to be an x-intercept. So over here to the side, I'm going to label x equals 4. That's one of my x-intercepts. How would I write that as a factored form? How would I write it? X minus 4. Okay, so that's one of them. That's the first one. We have another x equals 4. So we have another x equals 4, which means x minus 4 is another factor. When you look here for the last one, 2, I have negative 2, and that 0 is my remainder. So x equals negative 2. If I was to write that in its factored form, what would it look like? This last part down here is actually going to be my last factor. Even though it's not equal to 0 and we haven't solved it yet, we can actually rewrite it. So I'm going to rewrite this negative 1, and this is your constant and your x to the 1st power, by the way. This is negative 1x plus 4. We literally did this when we went over long and synthetic division. This is my last factor. But what was the leading coefficient in standard form? Negative what? Negative 1. That was my leading coefficient in standard form. You see how that negative is in front? It's combining that negative leading coefficient in that. Because if you look through, we started with negative 1 and we went all the way down. That's still our leading coefficient. So what I want to do is I want to factor that out because I want to have my leading coefficient to be at the front of my equation when I write it. So if I factor out a -1 here, what's going to be left in parentheses? This x minus 4 is your last factor. So let's write out all the things that we have. We have this factor, this factor, this factor, and this factor here. The -1 is my leading coefficient. So I'm going to write it out towards the bottom because let's be honest, I'm going to need the space. So we're going to have f of x equals -1. Please put that -1 first. The binomials, I don't care what order you put them in. I'm going to do x minus 4. We have two other x minus 4s. And we have one x plus 2. If I was to write that in factored form, that's too many x minus 4. Is there a way to combine that? What do you mean cube? So how would I write it? There you go. And then that x plus 2 goes at the end. That's a parentheses. So all three of those, if you see three of the exact same binomial, it's a slap in the face telling you, hey, your multiplicity is about to change. So for this question, it does have a multiplicity of 3. So this equation that I have highlighted, that's my factored form. -1 parentheses x minus 4 to the third power, and then x plus 2 at the end. Okay, I need to graph it. So in order to graph it, we already know what technically we know what our factors are, and we know what our x-intercepts, and we know our technical multiplicity. But I'll write it out here just to make sure. We have x equals 4 with the multiplicity of 3. That came from here. We have x plus 2, so I'm going to write that underneath. So x plus 2 is x equals -2. And what's the multiplicity on x equals -2? What's the multiplicity? 1. We have this. We labeled that here. We have this. We labeled that here. Look back at the first page. I have my roots and my multiplicity. What else do I need? The y-intercept and the end behavior. So for my end behavior, looking at the leading coefficient, here and here, technically, your leading coefficient is negative. And your degree is technically, you don't even have to look at these two. We know that 3 plus 1 is going to give you 4, but I also see that my highest exponent here is 4. So 4 is my degree. So 4 is my degree. When you have a negative leading coefficient and an even degree, what does that mean?
Down, down.
Down, down. So I'm going to highlight these in orange so I can see them. X-intercept multiplicity, direction, and now I need the y-intercept. You guys better not plug in anything for that y-intercept. What is it? 128. If you use the standard form up here, the y-intercept is just this guy. You can still plug in 0 for both of these, and you will get the exact same answer that we did. So the last thing that I need is the y-intercept, which is 128, and that's positive. That's all you need. Graph it. So I'm going to take this and graph it. So we're going to have x-intercepts here and here. I know it's going to go down, and my y-intercept is 128, so I'm just going to put it up here. And for the left at -2, it's going to cross through. Hit 128. It's going to go down towards 4. And take a second and look up, guys. The hardest part that you guys have is multiplicities of 3. Multiplicities of 3 need to have that cubic shape like this. So all I'm going to do, guys, is literally, once I get to this point, I go to my my x-intercept, which is 4. I'm going to curve it up, and I'm going to curve it down. So all I'm just going to do now is just try to connect this piece to make it look pretty. That would be my graph. Something like that. All the little squiggles and wiggles that y'all have in between, I'm fine with. The main things I check for are at the x-intercepts and the y-intercepts. Do you hit those at the correct kind of curve that they're supposed to be? And is the end behavior correct? That's all I'm looking for. If you go higher up than I do, I'm fine with it. We have 2 more questions. We're going to look at numbers 12 and 14.
What if, like, do like this, and No, and I was thinking of like, we're passing the negative to like curving it, but
So when you say curve it, you're talking about coming up and like coming back down or something?
not like bouncing over, like going through it, then curving it, then going up.
That's fine. Something like this and then curving it over to make, yeah, that's fine. Yeah, if you curve it differently than I do, I just want to check. Do you hit these and are the end behaviors going down? That's all I'm checking.
As long as it's like, you know, like bouncing.
Mm-hmm. All right, for question 12. Once I do 12, y'all are going to do 13 or 14, not 13. Y'all are doing 14. Okay, for 12. This one says a polynomial f of x and one or more factors of f of x are given. Factor completely using synthetic division. Hopefully you like synthetic. And you're going to write it in its factored form. And then you're going to sketch your graph. Okay, so what they've already told you is, hey, we've already solved this a bit. These two are going to be factors. That means that when I use synthetic division, my remainder should be 0. So let's confirm it. I'm going to take x minus 2, set that equal to 0, and x plus 1, set that equal to 0. We're going to solve. With these two numbers, I should be able to use synthetic division like we did a couple classes ago. And when I use synthetic division, if you look back up at the board, when I get 0 as a remainder, that means that it's going to be a factor. So what I'm about to do is use one of those numbers, and I should be able to get 0 for my remainder. So we're about to do that for this question. So I'll just take 2 to start off. It doesn't matter which one you start with. If you start with -1, you're going to get the exact same answer. We're going to start with 2. And I'm going to take all of the coefficients from this, and I'm going to put them in that top row. So -1, -3, 6, and 8. Hopefully you remember. Bring down, multiply, add, multiply, add, multiply, and then add again, which will give you 0. Is 0 my remainder for this? Yes, that's my remainder. So what that means is 2 is going to be an x-intercept, so that's perfect. Now I just need to pretty much triple confirm that with -1. Don't you dare redraw another one. All we're going to do is we're just going to continue this going down. We're just going to put a -1 outside, just like they did on the other page. Less work, make it easier. Heidi, what's the first thing I bring down for this? Good job. And now what? So -1 times -1 is what? Please don't tell me 2. And I'm going to add. So what's -5 plus 1, Heidi? -4. You're fine. And what's -4 times -1? +4. And then what's -4 plus 4? 0. Right up here. I recopied this. This is a -1. I just recopied it here. This one? Mm-hmm. Yeah, especially when it says both of these are factors. That means that when you do the synthetic division, this answer remainder should be 0. When you do synthetic division for this remainder should be 0 as well. It would still work. If you put -1 here and 2 here, you would get the exact same answer. Okay, so based on this, these two are definitely factors, and it looks like we have one more. So like how I was telling Gabria, we're going to have -x minus 4. And all I need to do, since I know that negative shouldn't be there, that's your leading coefficient. So we're just going to factor that out to make it x plus 4, and we have our last x-intercept. Our last x-intercept is x plus 4 equals 0. So I'm just going to subtract 4 on each side. X will equal, that is supposed to be a -4. So your last x-intercept is -4. Oh, before I box this, what's the multiplicity for each of those? 1. Unless it says something other than 1, we're going to assume that your multiplicity for these are 1. If that's true, with all these multiplicities, what's your degree for this? 3. And if you look back in standard form, your degree is 3, which means you have 3 x-intercepts. All right, I'm going to write out my factored form first, then I'm going to graph it, because technically with my graph, I need one other thing. F of x equals, what did we say the leading coefficient was? Look at standard form. -1. So make sure that that -1 that we factored out here, make sure that it's at the front. And it's technically the front of this as well. They're both the exact same. So we're going to have -1, and then I'm going to put behind it x plus 4, x minus 2, and x plus 1. These factors that I have here, these can be in any order you want. I'm just rewriting them. Last question before we graph it. What's the y-intercept here? Positive or negative? Graph it out. Oh wait, do we label the leading? Oh, we don't know the end behavior yet. End behavior. So we have a -1, and then what's the degree? 5? 3. If you have an odd degree with a negative leading coefficient, how's it going to end? There we go. That's what I'm missing. So let's graph this out. Now I have everything I need to graph. So I'm going to bubble my points. And I'm going to plot 8. Positive 8 is up here. So we're going to start up. Should look something like that. Those steps that we had on that second page where you're finding the zeros in multiplicity, you're finding the end behavior and the y-intercept, it's the same thing I did here. I just did it a little out of order. All right, number 14. That's the one you guys are doing. Really quick, it says for number 14 that x minus 3 is with the multiplicity of 3. What does that mean? Say it again. It does mean it's not cube, it's cubic. So it is going to be cubic, and something's going to be cubed. But when I'm doing the synthetic division, though, what does that mean? You're going to do it 3 times. So it's going to be 3 times. This is what I mean. I solved for x. The x-intercept is 3. I'm going to write my synthetic division out, and then you guys are going to finish it. All of the coefficients for the standard form, I'm going to put at the top. 1, -7, 9, 27, and -54. What that means is when you solve this, you should get 0 as a remainder. And you're literally just going to do the synthetic division again for 3. Same exact positive 3. Once you solve for this last number here, you should get a remainder of 0, and you're going to do the synthetic division one more time. So you're doing synthetic division 3 times for the exact same number, and it's going to simplify. So I'm going to give you guys a few minutes to get this done, 3 minutes, and then I'm going to put up the answer in factored form and the graph. Make sure, just like how Gabriela was saying, this x minus 3 should be cubic. It needs to have a multiplicity of 3. So I have the synthetic division over on the left. I noticed that at the bottom I have x plus 2. That's my missing factor. So with that missing factor, I'm going to take that x plus 2, set it equal to 0. And that means my other x-intercept that I'm missing is at -2. At x equals 3, we know the multiplicity is 3 because we solved for that earlier. We saw that in the original problem. It said it has a multiplicity of 3. And at x equals -2, this one's just a multiplicity of 1. It's only one answer that has that. With the end behavior, so that's the next thing I'm going to write out. For the end behavior, keep in mind that you have a leading coefficient of +1 and a degree of 4. So with my leading coefficient being positive and my degree being even, both ends of your graph should be going up, correct? And the last thing I need to know is what's the y-intercept? -54. All right, so let me write out the equation first in factored form, and then I'll actually graph it. So f of x will equal, remember, the leading coefficient from this standard form should be the same for the leading coefficient here. So it's going to be a positive 1, which I don't need to write. I'll put x minus 3 to the third power, so make sure that x cubed is, or x minus 3 cubed is there. And then I'll also put x plus 2. That's my equation. If you want to put the 1 in front, you can, but on tests and quizzes, especially if it's multiple choice, I'm not putting that 1. All right, for my graph, I have a y-intercept down here at negative 54, and I have these x-intercepts, 3 and negative 2. If you get stuck with graphing these guys, please look up. I'm going to have it come down this way. It's going to cross through. I'm going to have it come down here to 54. I'm going to have it go up this way. And then when you get towards 3, a lot of students freak out and they're like, I don't know how to draw this. Literally, you know that it's coming from the bottom. So this side of the graph, I'm going to curve down. Let me curve it better. This side of my graph, I'm going to curve down. This side of the graph, I'm going to curve up. All I need to do now is find some way to connect it. That's it. If this is how your graph looks, I'll give you credit. I can clearly see that this is like a cubic function you tried to put through here. This is a linear function. It crosses the y-axis and both ends are going up. That's all I want to see. Questions or concerns?